Striped bass are one of the most important recreational sport fish along the U.S. Atlantic coast. Fishermen revere them for their meat, but also for the enjoyment of catching and experiencing their power. On top of their cultural value, striped bass fisheries provide thousands of jobs and inject millions to billions of dollars into local economies from Maine to North Carolina. Despite their importance, the Atlantic stock is currently overfished and experiencing poor recruitment. Catch and release mortality, otherwise known as CRM, is one of the primary sources of striped bass mortality along the Atlantic coast, resulting in approximately 50% of total take in recent years. This estimate comes from a fixed 9% CRM rate that, for over 20 years, has been used to manage the striped bass fishery. However, this percentage does not account for seasonal differences or an ever-warming environment that is predicted to exacerbate CRM by increasing the likelihood of disease in striped bass and low oxygen events in their estuarine refuges. Without accurate CRM estimates, mortality could be misrepresented, leading to uncertainty in management, unwarranted pressure on the fishery, and lost fishing opportunities. Therefore, George Mason University's Fisheries Ecology Lab, along with the Nature Conservancy and the University of Maryland Center for Environmental Science, are reassessing CRM as part of NOAA's Bycatch Reduction Engineering Program. Because many past CRM studies on striped bass utilize holding pens or tanks in a lab, we wanted a fresh evaluation in the fish's natural environment, or in situ, where the fish could act normally upon release. As such, we chose the Patuxent River in Maryland to be our study site, mimicking conditions of the Chesapeake Bay and a restricted tributary, which allowed us to assess CRM in situ using acoustic telemetry. Acoustic telemetry is a valuable technology that tracks the movement of fish underwater using listening devices planted in known locations that detect acoustic tags attached to fish. In other words, we can infer if a fish is alive or dead based on how it moves after release. Step 1 was obviously catching a striper. We used light tackle, just jigs and plastics, to mimic a popular recreational angling technique throughout the Atlantic. Once aboard, we took a few length measurements to get an idea of the size distribution we sampled throughout the study. Step 2 involves the tagging of the striper. We chose an external tagging method because the study is short-term and it eliminated the need for surgery, which could lead to death, resulting in imprecise CRM estimates. External attachment also aids our ability to collect valuable data while mimicking the recreational catch and release fishery as closely as possible. Putting a wet towel over its eyes soothed the fish and reduced thrashing, which was better for everyone involved. Once a few scales were removed, which we retained for aging, we used a needle to feed a vinyl floy tag through the back of the fish. We then attached the acoustic tag to the floy via dissolvable suture. This allowed the tag to be dropped from the fish once the battery died, which we tested in the lab prior. Once the floy was tied and cut short, our striper was ready to be returned to the water. Step 3. The release. The striper was supported and gently lowered into the water. Upon release, we recorded condition on a scale of 1 to 5 and inferred post-release fate utilizing roughly 2 months of acoustic telemetry detections. In addition to providing an updated CRM estimate, we wanted to evaluate the relationship between CRM and temperature, as striped bass fishing occurs from the start of spring to the end of fall. Therefore, we caught 47 fish in the spring, 28 fish in the summer, and 22 fish in the fall to assess temperature across the entire fishing season. While successful in lab experiments, there was no guarantee that our external attachment would be effective in the field, as this method has never been put into practice on striped bass. However, by partnering with CCA Maryland and Tag Chesapeake, it allowed reporting of several recaptured tagged fish, demonstrating that the timed released external tagging produced reliable movement data for the life of the tag. Across all seasons, there was a 1% CRM rate within the first 2 weeks and a 7.7% rate after a full 8 weeks. Summer had the highest CRM at 11.1%, followed by spring at 6.8%, and fall at 0.29%. but error among seasons overlapped. Furthermore, as the water temperature increased, the mortality rate increased starting at about 25 degrees Celsius. This was apparent at weeks 4 and 6 post-catch, with a statistically significant relationship at week 4. Given that most of our mortalities were delayed, greater than 72 hours post-release, it is important to note that these mortalities could be caused by anything. Our results are a worst-case scenario. However, the similar patterns among spring and summer support CRM as a probable cause. So what are the next steps? Due to our CRM rates falling below the current 9%, this study, and others, suggests that light tackle fishing with artificial lures could reduce CRM when compared to other gear types. Additionally, increased temperatures increased CRM as expected, demonstrating the importance of seasonal management regulations and variable CRM estimates. In the future, we hope to compare the most popular gear types, such as trolling, live lining, and light tackle, among seasons to investigate the interaction of temperature and gear type on CRM. The results of our study, and hopefully studies to come, provide accurate science to managers and policymakers, allowing them to make informed decisions to conserve striped bass and sustainably manage this prolific fishery.